Okay, friends, so last week you had a bunch of assignments to do on Envisions, helping you learn how to multiply decimals. Some of the assignments focused on multiplying a decimal by a whole number, and some of the assignments focused on multiplying two decimals together. I wanted to take the opportunity to do my own presentation to you about multiplying decimals. I used this example from the video on your Envision site. Please make sure that you're logging into this site every day and doing one video and one digital quick check. Don't let those assignments pile up. These are important parts of your math instruction that you need to do before you take quizzes and tests. Let's go ahead and read the problem and see what we can figure out. Barry displayed 4 paintings side by side in one row, and we can see the 4 paintings here. 1, 2, 3, 4. And they all have different heights, but we're really not focusing on their heights in this problem. We're focusing on their width from side to side. And it tells us that each painting is the same width, meaning this painting has the same width as this painting, as this painting, as this painting. And then we have to figure out what the total width of the row of 4 paintings is. Now, if you want to be algebraic about this, you could write an expression to represent how you're going to find your answer. Each of these 4 paintings has a width that's a little bit less than half a meter. Half a meter would be, of course, if it was 5/10 of a meter, that would be exactly 1/2. Since we have 36/100 of a meter, we know that that's less than 1/2. Since there's 4 of them, we can multiply 36/100 times 4. And our answer, which we can name n, will represent the width of our 4 paintings. We could give it any letter we wanted. We could name it n for number, we could name it w for width, we could name it p for painting. This is something that is good for you to get into the habit of doing. When you're trying to solve for an unknown number, like in this problem, write your expression, put an equals sign, and then give your answer a variable that represents your unknown number. That's what you're trying to figure out. Okay, so we're going to multiply 36/100 times 4. And let's just pause and remember that the meaning of multiplication is, of course, repeated addition. So we know that we have 4 groups of 36/100. We could also say that we've got 36/100 plus 36/100 plus 36/100 plus 36/100. 1, 2, 3, 4. All of those would be accurate ways of representing the problem. I set up this model on my desk to help you visualize what I'm talking about. Here I have a group of base 10 blocks, and I set them up to show you 1/10, 2/10, 3/10, and then 6 little itty bitty individual hundredths cubes. So here I have one group of 36/100, and in order to solve my problem, I need to show 4 of them to get a total width. So here's what that model would look like, 4 groups of 36/100. Let's first focus just on our tenths. We've got 3/10 plus 3/10 plus 3/10 plus 3/10. Let's bundle those up together and see what they look like when we put them all together. So I've got 3/10, 6/10, 9/10, and 12/10. And of course, 12/10 is the same as 1 and 2/10. Because I've got 3, 6, 9, 10. So 10/10 is 1 whole, and then 2/10 left over. So that's my 2/10. Okay? So 3/10 times 4 equals 1 and 2/10. Now let's look at our hundredths. So I've got 6/100, 12 hundredths, 18 hundredths, 24 hundredths, so 6 hundredths times 4 equals 24 hundredths. So then my total is going to be 1 2/10 plus 24 hundredths for a total of 1 44 hundredths. Let's try to put that number into context. If we say that the total width of these 4 paintings is 1 44 hundredths of a meter, well, think about this. 1 5/10 of a meter would be exactly 1.5 meters. So really, we're saying that they are very, very close to 1.5 meters wide. I want you to just focus on this for now. If you looked at this and it made perfect sense to you and you felt ready to try a more efficient strategy, I will tell you that when you have your quiz on Friday, the quiz will focus more on understanding a decimal model using base 10 blocks or a decimal grid, and your quiz will not require. Okay, now I'm going to show you a more efficient way to do that multiplication. Remember, in math, when we're learning a new skill, it may be easier for you or a more reliable way for you to get the right answer to get the solution by doing the slower and less efficient strategy. So in this case, that would be doing the repeated addition or counting up your tenths and then counting up your hundredths, and that is perfectly fine. When you feel more comfortable and confident with multiplying decimals and you're ready for the most efficient method, then you'll start to do this method of multiplication. We're going to stack up our numbers, and you're going to notice that I did not stack them up by place value, meaning my 4 ones is not where it would normally be in line with in the ones place. So that is something that is a little bit different about this method of multiplying. We don't need to worry about lining up the numbers by place value. What we're going to do is we're just going to ignore this decimal point for a second, and we're going to just go ahead and multiply this as if it was this problem, 36 times 4. Then we're going to place our decimal point where it needs to go. So we're going to go ahead and multiply 4 times 6, which is 24. Put down the 4 and carry your 2. 4 times 3 is 12, plus 2 more is 14. Now we need to figure out where to put the decimal point. And I'm going to go into a lot more detail about why we do it this way in the next few weeks, but for now, I'm just going to simply tell you that if you have 2 place value positions in your factor here, then you need to have 2 place value positions to the right of your decimal point in your product. So for this problem, the decimal point will go here. 2 place value positions to the right of the decimal point means 2 place value positions to the right of the decimal point in your product. Now for number 4, we don't have any digits to the right of our decimal point, so we don't need to worry about that. Okay? Now if this is confusing to you, you can practice it this way. To solve it this way. Let's look at another example. Okay, now this example asks us to multiply these 2 numbers, and the context or the story problem tells us that Nancy walked 1 7/10 miles in 1 hour. So this is like saying she went for a walk and she went a little more than 1.5 miles. If she walks at the same rate, how far will she walk in 1.5 miles or 1.5? Sorry, I didn't say that right. If she walks at the same rate, how far will she walk in 1.5 hours or 1.5 hours? This is a multiplication problem because it's telling us that she walked for 1.5 hours at this consistent speed, and we need to figure out what distance she walked. For this problem, I think it's helpful to draw a number line. And let's imagine that this number line represents kind of like a map of her walk. So she started here, she's feeling energized and refreshed and ready to go, and she's walking along on her little number line. So we have to figure out how to mark this number line to make it useful for us. So let's say that she's walking along and she has a timer or something, and the timer tells her when she's gone a half an hour, and an hour and a half. So here we'll mark this 1/2 an hour, or 5/10 of an hour. Then we'll mark her 1 hour time, and then we'll mark her 1.5 hour time, or 1 5/10 of an hour, and 2 hours. Now we know that she never did this distance at all. She only walked for 1.5 hours. So she went from, she went from 0 hours to a half hour to an hour to 1.5 hours, and this is where she stopped. So let's think about this. In 1 hour, meaning from here to here, she was able to go 1 7/10 of a mile. And then if she had gone a full 2 hours, she would have gone another 1 7/10 of a mile. But because she stopped here, our job is to figure out what her distance was. We can figure this out by multiplying her consistent speed multiplied by her time. And remember, when we multiply decimals, we're going to start out by multiplying them as if the decimal point wasn't there. So we can multiply 17 times 15. So pause the video and go ahead and figure out what that would give you. Let's see, 5 times 7 is 35. 5 times 1 is 5, plus 3 more is 8. Put a 0 here to hold my place. I'm done with my ones. I'm done carrying that. 1 times 7 is 7, and 1 times 1 is 1. Now I need to add my partial products. And that gives me 2 55/100. So now the question is, where does our decimal point go? It makes sense to say that the amount of distance she was able to go is probably between 2 and 3 miles. So I'm going to predict that our decimal point goes here, because that would show about 2.5 miles that she walked. Remember, our rule for this is count up the number of decimal place positions or place value positions to the right of your decimal point. In this problem, we have 2 place value positions to the right of our decimal points. And so for our answer, we have to have 2 place value positions to the right of the decimal point. So therefore, yes, I was right. The decimal point should go right here. She walked 2 55/100 miles in that 1.5 hours. And if you want to check it on a calculator, I invite you to go ahead and do that and make sure that I put my decimal point in the right spot.